Okay, so we're going to do a quick review of the elevator type problems. And while we're doing the elevator type problem, we'll also talk about forces being applied to an object. So if I have an elevator, the elevator is going to have forces acting on it to cause it to either accelerate up, move it, or accelerate down, or even if it's moving at a constant rate, it must have a force on it. The elevator itself is going to have, for example, a person standing in the elevator. If the elevator is not accelerating, then the tension in the string, the force in the string, has to equal the mass of the person times gravity, because that is going to be what force is needed to hold it there if it's not accelerating. In this particular problem, let's assume that the elevator itself has a mass of 0. That isn't exactly true, but in this case, we can make that argument very easily because we're just going to talk about the impact on the person. And so the person will see their weight as their apparent weight as equal to mg. If the person is now accelerating upward, what we find is that as they accelerate upward, the tension in that string has to equal something a little bit more, because if it's just pulling with the mass of the person times gravity, then there's no extra force to cause the acceleration. And so you would have to have some additional force on here, and that additional force is going to be the additional applied force to cause this thing to move. Applied just means any force that's not gravity or is not caused by one of the forces defined somewhere else, like the electrical force or the magnetic force. It's applied, just a fancy name for any other force. So there's going to be a force in the string here. It's pulled on by the string, equal to an additional force that's going to cause it to move. And that force is going to equal the mass of the person times the additional acceleration that the person is going. So in the case of the person going up, when they read their scale reading, they're going to find that their weight is going to be greater than their parent weight is going to be greater than their weight when they're just standing on a scale with an acceleration equal to 0. In the case of this over here, this would be when the acceleration was equal to 0. Then we talk about the other scenario where the elevator is going to be going downward and accelerating downward. And so acceleration downward would mean that the applied force could actually be less, that you actually need to be pulling up with less force than their weight. So the sign of this would be changing to minus, and in that particular case, the applied force is less than their weight. So when you're accelerating, it's all about acceleration. If acceleration is 0, then the velocity is constant. And if the velocity is constant because the acceleration is 0, then the weight is not going to be anything other than their actual weight standing on a scale in a non-accelerated frame, such as in your bathroom. If you are accelerating in an elevator, a car, a spaceship, what you are going to see changes because you need forces acting on you that are greater than your actual weight. If you only push with your weight, you only are going to move at a constant velocity. The forces are going to cancel out. If I have an elevator and you're pushing down on the elevator with a force, your weight, and the elevator is only pulling up with a force equal to your weight, there is no acceleration. To get acceleration, you need additional force pulling up. If the acceleration is positive, then that means that is bigger. If the acceleration is negative, then that means that is potentially smaller than the weight itself. And so the weight wins, and so you are less. If it's greater, it's more. If it's constant velocity, which could be constant velocity of 0, not moving, or constant velocity of +2, or constant velocity of -2, or +7, or -7. It really doesn't matter. As long as it's constant, then you have no additional force on you other than your weight.